Hello, and welcome to CodingKoans, where together we're going to explore the world of software, get better jobs, and change the world. My name's Carroll, and I have kept my voting sticker very pristine on several different shirts. By the way, now is the season for voting, as in the only time really ever where it's super duper 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 gonna matter. So if you haven't voted, I would strongly encourage you to do so. That being said, I have a guest today, and we're going to explore some game development together. My guest is Joseph Limbaugh. Joseph is an improviser and a game designer. You can check out his work on postcardgames.com and in connection with the game Gatefall, which you can currently find and the expansion on Kickstarter as Lost in the North Woods. He teaches improv to lawyers, actors, and at the New York Film Academy in Los Angeles. Joseph, welcome to the show. Let's start talking a little bit about game development, because you were in here. You're a game designer, but oh, hold on a second. I just realized something. This whole time, you've been muted.
Are you serious?
Yep. Okay. But let me ask you that question again about game development. Your thoughts about game development in board games versus game development in software.
Right. Well, they're very similar because you're developing systems and and you want the players to make interesting decisions, fun decisions. I think that's foremost in your mind. And you want balance is important. Like you want a system that the players can't break. You know what I mean? So I think that is something that exists both in board games and in computer games. Like I've been a play tester for computer games. I used to work at Activision down in the dungeon, as a
Okay.
play tester. It was one of my first jobs in
Oh,
Los
really?
Angeles. And yeah, and it's like that's actually kind of a fun job because you play games and your whole job is to break them, so that they cannot be broken by other people. But you try to like exploit the game and find the edges of it, and it's really important to have good play testers for any game to make sure that that it isn't easily breakable by the end user, right?
That's also very important if you're putting together a website that gets people pizza delivered or something. You
Right.
know. Uh,
That's funny because I'm having not pizza but Italian food delivered in just a moment, so we might get interrupted by that.
Yeah, it's so yeah. I mean, like one of the things that I'm thinking about, like in my job as a web developer, that's not really developing games, but I'm thinking of the way in which a user will experience this piece of software, so that it is intuitive for them to figure it out, not easy to break, simple to them, makes sense, and fun and rewarding to continue to use. And I don't think that those things are something that should only live for concerns for video games.
Absolutely. Yeah, one of my like gurus in game design is Chris Crawford. I don't know if you've heard of this guy.
I
I wonder
haven't.
if I have I wonder if I have one of his books here. I might have something. Yes. Oh, I do. This is actually I should loan this to you. This is Understanding Interactivity.
Oh, cool.
Yeah. This is a great book because um I don't know, he's like an old curmudgeon. He will even say that he's an old curmudgeon.
Uh,
But like that is probably like one of the best books I've ever read on interactivity and like a design of user interface. Like it kind of lays out, it describes what interactivity is, first of all, which is a word that gets thrown around all the time. But like his description, like his explanation of what interactivity is priceless. Like it's oh, that's a great way of looking at it, you know. That's a great way of describing what interactivity is, because a lot of people get confused. Like interactivity, like movies aren't interactive, right? That's a thing that is great about computers, is they're interactive. But
right.
what does that mean? What is interactive? Like, I mean, this pencil's interactive, I'm interacting with it. But like, he's like, okay, well, this is what interactivity is, and this is why computers are different than all the other types of medium, and why people get this wrong is because computers are interactive, and this is what interactivity is, and how to best design it. Anyway, he's like an old curmudgeon, and he's been trying for years to develop interactive storytelling, which is like and people, once again, that's another buzzword that people talk about all the time, is having narrative in a computer that is interactive narrative, kind of like doing what we do as improvisers. You know what I mean? Like creating a story in real time in a computer. No one's really done that. People say they've done it, but they're really just using the same technology over and over again.
Right.
It's like a branching tree or whatever.
Right. Yeah. I mean, you can only get so far with branching, and that's because, and I'm the perfect example is Dungeons and Dragons, right? Or at least I'm going to say it's
tree?
A perfect example.
It's an example of a game system, but
sure.
You mean
okay.
of a branching system?
Let's at least the way that I played Dungeons and Dragons, or for that matter, I could say the same thing about any tabletop RPG, which is that as a player, I can say I want to do anything at all. Anything I can think of can happen, and there's going to be a cause and effect, and there's an interactivity to that. But the interactivity is with a person who's the game master for that. And that person is going to be interpreting what you're giving them and then giving you something back.
They can let you go anywhere, though, right? Like if I'm a person, I'm the game master, you can go off the rails off to wherever, and I can like design it out for you. But a computer can't do that, really, right?
Right, exactly. You can design it on the fly, right there on the moment, as like, oh, I wasn't expecting them to do that, but we can work with that. Yeah, I mean, like branching actually doesn't get very far even for something like chess. Chess will get you, like, there are more possible, if you were to build the entire game tree for chess, like every, option followed by every possible option that comes in after that. There are more games that are possible of chess than there are atoms in the universe times milliseconds since the Big Bang.
But it is something that a computer can calculate. Like computers can now beat human beings at chess.
They
can't calculate all the they can't calculate all the possibilities, but it's a problem they can at least approach. Whereas I would say the problem of creating storytelling is even more complicated than that.
It is massively more complicated than that, because this has chess. Rules of like there's a this and then there's a that. There's a call and a response, and it's just call response, call response. But with storytelling, that's even more complicated.
Anyway, that's something Chris Crawford has been it's a nut he's been trying to crack for decades. He created this system called Storytron and had a bunch of people working on it, and just wasn't happy with the results, and it wasn't, he's been trying to solve that problem for a long time. So he's a really interesting guy. But yeah, like I said, an old curmudgeon. He would always say, like, if there's a problem with software, that you should shoot the programmer. Like, it's like if you as an end user are confused, then the programmer has failed. Yeah. And his hyperbolic response would be, shoot that person who wrote that code, because it's their fault. It's not your fault. Yeah. Everything should be clear.
And a lot of times that, just to go a step further and say, like, it is our responsibility as software engineers to write code that other people can use. It doesn't matter whether it compiles or how clever we are. That's not the reason why software is written. Software is written for someone else. And if you fail to actually write the software for someone else, then you're doing a terrible, terrible job. I mean, it's sort of like writing a love letter, but all you're doing is focusing on the grammar and the penmanship. You can feel that if someone does that.
Yeah. Yeah, I think like the perfect example is anytime there's a menu item that's grayed out, there should always be a tooltip that says why it's grayed out every single time. At no point should I see an action that I want to perform, be unable to perform it, but not know why. But that happens all the time. I'll go into a menu and stuff's grayed out, and it's like, you need to let me know why it's grayed out, because I don't like, especially with like modern software, there's like so many things in menus now. It's
like a mystery. It's like, I want to get there, but the bridge is out.
The bridge is out. Yeah.
How do I? Now the game is, how to order this pizza, but the bridge is out. But this is not a fun game to play. This is just an irritating game to play, and it just makes me feel like a lot of people get the feeling like software like has a life of its own. It's like, oh, it's computers. It's like, no, every single thing that's in a computer, someone's had to sit down and write. There's nothing in a computer that someone did not write. They might have written a program that writes a program. That's possible, but you know, yeah, it is the responsibility of the developer to write for people. It looks like your pizza may be here, or
Yeah.
your Italian food, or is there a complication?
I don't know. Hopefully, I think someone's taking care of it.
Okay, well that's good.
Let me just, you know what? I can also look at the camera. See, well, there's no one there, so hopefully that got delivered.
Hopefully.
Anyway,
Maybe so. We're going to work on some Unity stuff, right?
yes.
All right. I've never. I have opened up the Unity program like once. Tell me, what is Unity and what does it do, and why should I consider it as a tool?
Oh, those are all good questions. Well, Unity is a really popular game development platform, right? It's like really popular. I think the two big ones are Unity and the Unreal Engine. Those are kind of the two big platforms. Now, Unity technically, like it's called Unity because you can develop for many different systems. Like you can compile for like Mac, you can compile for PC, Android. I think like PlayStation. I think like it does. You can set the parameters to compile for an iPhone. It is. That's why I think it's pretty popular, and also it's free for like students. There's like or really anyone. I think if you're like you're not unless you're planning on making $100,000, I think the platform is free to install and use, and there's a big user base. So, and that's one of the things that draws me to it.
Oh yeah,
because
you need a big user base.
Yeah, you can look up any error, and there'll be someone who's dealt with it. You know what I mean? Now there are downsides. It is very complicated. And a bit kludgy. Like there are definitely some weird. It's a huge, complicated, gigantic beast. So there are definitely like occasionally you'll run into something where it's like, why is this error popping up? And you go and you look on the forums and they're like, oh yeah, this is an error. Unity itself, it has nothing to do with you. And here's the workarounds. You know what I mean? So there's that, but that's, and it uses Visual Studio. Like it's connected to it. I'm not sure. I think you might be able to use a different text editor now or different, but generally you're using Visual Studio. So if you don't like Visual Studio, and I mean, I don't know,
it's a fine editor. I mean, it's not my editor of choice, but I mean, an editor is an editor is an editor.
Right. So. Well, I mean, I just had to because I haven't run Unity in a while, and I just started it for this. And then when I pulled up Visual Studio, like it took a long time to start, which is pretty normal.
Yeah, that's
and then when it started, it's like, oh no, you don't get any Visual Studio yet. Your license is old. Like it gave me several warnings that I had to hoops I had to jump through, which were just like I have a free license, so I just clicked on no, it's not, and it's like okay, you're good. So, and then I had to sign into Microsoft or whatever. But
now that's the difference between proprietary tools such as Unity and Visual Studio and the world of open source. In open source, there's frequently there can be a lot of bugs in open source, but the difference is that the hood of your car isn't welded shut. You can actually open up the hood, go into the gears, fix the thing you need to fix it for everybody, and then you're good to go. And you've contributed to everybody. You've solved the problem. There's no workaround. You've actually solved it. You also don't have the problem with the licensing and other things like that. But because the fact that this is developed purely in shop by Microsoft, I believe, for Visual Studio, I'm not sure if they own Unity. I think that might be somebody else.
I don't think they do. No, Unity has a contract with Microsoft to use Visual Studio, but yeah.
But
the code is C sharp. Like that's the Unity code is all C sharp generally.
Yeah.
You used to be able to do, it was either C sharp or JavaScript, I think.
Huh.
You had an option between, like, I think it was JavaScript. Was
Was
it
it
JavaScript?
Python
I don't
maybe?
remember. Maybe Python. Actually, maybe, yeah, it was Python. You had an option, but now I think it's just C sharp,
Yeah, they
which is
want
one of the
it.
reasons why they use Visual Studios.
All,
So.
but C Sharp is open source because it's a programming language, and a closed source programming language is not a great idea. Um, Not that people haven't tried, but it is also owned by Microsoft, or at least that's who's maintaining it primarily. So yeah, not too surprising. But C Sharp is a fine language. It's very similar to Java. It's typed, so it also you could write unit tests for it, which is kind of cool. I don't know if that's really done.
What are unit tests?
So it's a way of handling low-level bugs in a program. So instead of having like play testers find the bugs and then you fix those bugs, what you do is you write unit tests for each little tiny bit of code that you're writing. You validate with 100% accuracy that it does exactly what you say it's going to do with this test that runs that little bit of code, just that part, make sure it works. And then you have like hundreds or even thousands of those as you're working that validate that all of these little tiny issues, they're all solved. They're still working.
Right.
If you change something, you didn't accidentally break something over there. You've got these unit tests to prove that you did not break anything that you're already testing.
Oh, cool. All right.
Which,
I think I understand that.
yeah, so what that does is it means that your play testers can focus on game feel. They can focus on the aesthetics. They can focus on like really obscure bugs. Otherwise, you're really trying to develop your software with your game testers if you don't use any tests. I'm not sure how much the gaming industry uses unit tests, though. It might depend on the shop.
Yeah, I don't know. I mean, I definitely know that testers are working, like they will play the game before it's finished. Like
Oh,
that's
yeah.
kind of the whole point. Like
Yes.
they will be playing,
And they ought to. But to take the load
yeah.
off of them and you don't need them except for things that a human can do, or that you can squirrel out that way. They're still very useful, and they ought to. You ought to use game testers. You ought to use QA people, but you can give them less work and give them more valuable work to do if you use unit testing, and you make sure your code base is clean that way. But you've got Unity set up, right, on your computer?
I do, yeah.
All right, you want to share your screen?
Sure.
All right, let's see how this goes. Okay, so I'm seeing.
Oh, hello? Ian? You disappeared from me.
Can you hear me now?
Oh, you're back. You're back. You
Hold on.
disappeared.
I need to put my headphones back in.
Okay.
That was a little thing with the camera. I forgot to plug it in. It's running off of batteries, and that was when the battery died.
Always solving technical problems in this world we live in.
Yeah, well, I have a pre-flight checklist that allows for me to do some unit testing before this happens, so that when something does break, it's pretty obvious what it is. So,
Well,
sorry
that's
to
cool.
leave you in the lurch for a second there.
No, that's fine. I was worried. Can you see my screen now?
Yes, I can.
Yeah. So,
So, what
I
are we
first
working
let me
on?
just say that I'm not like a trained coder, so I probably have broken all sorts of good practices that most most people who write code would like to follow. This is not, my whole thing is like I want to make something that works, and so that's what this is. And Unity actually is great for that because you can get some stuff happening almost right away just by sitting down and building some stuff. That's one of the cool things about it.
Cool.
So this is Unity. These are the different sections. This is the hierarchy over here. So these are like kind of all of the objects in my scene. Like if I click on one of these, you'll see that this ring is selected. That's the other ring. Um, some of this stuff is old and probably isn't active.
Okay.
Um, and then yeah, so these are various things within the game. You can kind of move around, and this is so it has a very much like almost 3D modeler approach to how you do stuff in Unity. So you have kind of this place where you're building objects in here, and then you have kind of the objects you built over here.
Cool.
Um, and down here is I forget what this is called, the project manager, I think. But these are kind of like all the different objects you have, and scripts and textures that you have imported, audio assets, basically all the different assets you would need for your project. And if you're smart, you've organized them well. I probably have not organized them well. I'm sure there's probably versions of those. And then like if you click on a specific object, like you can either click on it over here, or like over here is this ring, which is, these are just environmental. They don't really do anything in the game. They're just environmental objects. You can
Okay.
go over here to the object inspector, and this has all of the different, like you can see here's the transform of the object, like its position, rotation, and scale, all of the different kind of elements of that object, all the things attached to an object. And most of those are things that Unity gives you to put on, like like the animator. An animator is something that you use to animate an object, like the shaders that show what the object looks like, all of that. But like if I go, let's see, to take a look at the player arc, which is kind of the player object, you can see over here in the inspector that has scripts attached to it. So that is where in Unity you write scripts, is you have scripts that are attached to the object itself. So you can
Okay.
like add a component. These are components, by the way. You can add a component, and then you can add like a new script component, uh, and then one of these scripts will appear. And if I go like, this is the name of this is the actual script here, Overdroid Orbit. If I click on this, it will pop the script up, and this is the script that is connected to that.
This is looking more familiar to me at this point now that I'm seeing text.
Yeah. Now that you see text, you can see what's going on, because this is where the actual coding happens. This is the C#
Yep.
that is behind all of this. And
So
I
you
forget.
use these scripts when you want to do something that's super custom. That's not necessarily what the other parameters that are in your graphical user interface would allow you to do, right?
Correct.
Okay.
Yeah. So you can see I'm setting up some variables here, speed and smooth.
And there's a
Um,
6F and a 3F. Are you using, now, F in this case, what does the 6F mean?
you know what? It's been a while since I've been in Unity, so I'm not sure I totally remember what that means. But if we go back to here, you can see that I think it might have something to do. I
Yeah, I'm
don't
seeing
totally
those
remember
numbers,
that.
6 and 3.
But yeah, so these are like, I can change these numbers. One of the cool things about this is I can change these numbers, and they're public. If they're public numbers, I can change them, and then that'll change the behavior in the game.
Oh, okay, hold on a second. Could you change that to um, uh, 6.2? I don't know.
Okay.
I was going to be clever, but I failed. And then if you change to 6.2 for the speed, if you go to the script, does that change the script also?
I don't think it should. I don't think it'll change the script, but I might be wrong. No, see, the script is the same.
Okay, so the script is not generated by by Unity.
No,
Okay, so I'm
no.
seeing that you've got a speed here 6F. Maybe the F in this case means float. I don't think that you're
I
using
think it does. I
hexadecimal.
think it. I think it just means float. I think it means. Yeah, I think it's definitely not hexadecimal. I think it means float. It's just a quick way of, I think, of writing float without putting 0.000 or whatever. It just automatically
Mhm.
casts it to a float. I think for whatever reason, uh, I had to do that. I don't know why. I
Yeah,
wrote. By the way, I worked on this game like years ago,
Yeah.
literally years ago, and since I've worked on it. So some of the stuff I don't, and Unity's been updated multiple times. So some of this stuff, like, probably is not written the way it should be written
Well,
in the
we're
current
going to
version of
find out
Unity.
what is and is not written in a decent way based off of, how many questions we have and what kinds. Because
Yeah.
I imagine you from 3 years ago understood this very well.
Yeah, I think I did. I mean, yeah, I mean, I spent a lot of time working on it.
Yeah.
So let's go back to the to Unity. So one of the cool things now about Unity, you can see here, like that's if I click on scene, that's scene. Then you can click on game. The game isn't running, so it doesn't really look like much, but that's what it will kind of look like from the camera view. If I hit this play button right here, then the game will run. Um, so if I do this, then we will actually see. Oh, here we go. Yeah. So this is the game. This is the game running right now.
Okay.
It
And
has
there's your.
spawned this thing in the middle. I can use my keyboard and mouse to kind of move around the outside of this sphere. Which, by the way, this is a game that this is like an update of a game that I wrote, like in the early 2000s. I wrote a game for a competition called, it was a dark basic game competition. And that's where the name Overdroid comes from too, because it was supposed to be an update of a game called Paradroid, which was on the Commodore 64 years ago, like in the 80s. And this is only part of it. Like in the Paradroid game, you're this robot that takes over other robots, right?
Okay.
You go into their brain and you take them over, and then there's this little mini game where you have to like shoot their little circuits to like create to take them over. It's like a little mini game. So this was kind of a 3D version of that mini game that I created. This is a long explanation of where Overdroid comes from and where also kind of the name of this game would have been Overdroid. But there's no robots, obviously. This is just you kind of taking over the robot on the inside of their brain. So here's the thing, you want to turn, it's kind of like a little puzzle, and this is like level 1, so the puzzle's really simple. But what you want to do is turn all these red cubes to blue cubes. So if I shoot these cubes, and here's the thing, this is the puzzle part of it. See how there's these lines connecting these cubes here?
Yeah.
If I shoot this cube, it flip-flops, it toggles all the cubes.
Uh-huh.
Right? So you have to to get them all blue, you have to like do this. Right? Because it'll only toggle the adjacent cubes. And then if I do all of the cubes blue, then it'll like this is kind of as far as I got. It'll create, and as you keep doing this, it'll get more and more difficult. Like the cubes will become, the puzzles will become more complicated. And I think I can
Is
switch it to a higher level so we can see like a more
is
complicated puzzle. But
are those are the puzzles, are they being generated or did you
they are
design
generated.
each? Okay. That's really
No,
kind of
there's
cool.
in fact there's a recursive script I wrote. I don't. I will have. Maybe we can look at that if you want to. But I wrote a recursive script that designs the puzzle that I was really proud of. I think it's like the first time I ever wrote a
Yeah, well,
recursive
let's
script.
let's see that. First of
And
all,
this is a cool thing too. I can like pause the game. I can escape out of it and then go look at stuff. Like I can go and I can change things. Like I can change this number in the middle of the game,
to
right?
see
And now
how
when I
that
go in
plays.
here, the speed is slower. Like I'm moving slower around the sphere. Yeah, I can. That's one of the cool things about Unity is I can go in and like alter this
Oh
stuff
man.
while to see like how does it work, because you're an artist, you're building this game, you want to be able to change that stuff and
So
see
as a developer, you're also kind of play testing in order to see how it works for all those things that you can't unit test. You can't like this isn't a bit of pure logic that either works or it doesn't. This is something that's like this is all about look and feel.
yeah,
Um,
which is
so
really important for a game. And I
yeah,
think like if you are a game developer, like you generally will get very good at your game, by playing it over time, just because you spend a lot of development cycles, like playing the game, changing the code, playing the game, changing the code, playing
and
the
that's
game,
why you
changing
need the
the code,
play
stuff like
testers
that.
also because you can get lost in playing the game the way that you play it and miss other ways of playing the game.
Yup. Yeah.
Yeah.
So we'll stop this now, and you wanted to see. I'm trying to figure out where is. I think puzzles. I think spawn code is the script
Oh, cool.
that builds that builds the puzzle. That's got to be it, right? It's called
So
spawn core.
I need to shout out Puck90 in the chat. Hey, Puck90. Puck90 has a show on Outpost 13, and that is called Allison's Sci-Fi Library Super Fun Time. And in it, she reads a science fiction book, chapter by chapter, and it is great. Yeah, right now she's in the middle of, I can't remember the name of the book. I should be better, but I'm not. But
She can put it in chat, can't she? Can't she put it in chat?
She can put it in chat, yeah. In any case, though, check out that show also. It's really cool.
Yeah.
So let's look at this. So how do you do this recursion here? Okay, first of all, what is recursion? Maybe some of our audience might not know what recursion actually is.
So recursion is something that you get, I guess, in object-oriented programming more than others. But basically, it's like if you have a function is kind of like think of it as like a black box where you actually get these on the SATs. They have them now on the SATs. But it's like think of it as like a mathematical black box. I put some numbers in, or an object. It doesn't have to be numbers. It could be a complicated array of numbers, or it could be something from Unity. Like it could literally be like a shape or an image. But let's say you put a number into this black box, and it's inside of the function there are a series of calculations, and those calculations run, and then it spits out a number at the other end. It spits out some sort of like, this is what I've done to your number. Like let's say that like your function is sum. And it takes two numbers, because you can give it multiple numbers or like an array of numbers. It takes those two numbers, it goes inside, it adds the numbers together, and then it spits out the sum of the two numbers. So that's that's how I would describe a function. It does something. It takes some information. It does something to the information, and it usually gives you back some more information. Is that a pretty good description, or how would you change that?
Yeah, it's a good description of a function. I've worked with recursive algorithms building a tic-tac-toe app before, but I think my definition is a little different from yours. Basically, it's not just any function, but it's a function that calls itself inside of itself.
Oh, right. Yeah, I hadn't gotten to that part yet. I was just describing what a function was.
Oh, yeah.
So a recursive function calls itself. So if the function is sum, then within that sum function, there would be another function that's called the sum function. And then at a certain point, though, you like that could create an infinite loop. So you have to have at a certain point, like there has to be at some point, like whatever number it spits out, it's like, I'm done. We've gone as far deep as we can.
Yeah, and then
it unravels each of those, closes out each of the iterations, and then whatever the final result is.
So it spins itself up, gets through all these different steps, and then comes back through. When I was doing tic-tac-toe, I would use Minimax to decide whether what the best move was. So it would actually traverse the entire game tree using recursion, trying to find the best move, and then come back and score each of the squares with that recursive algorithm, and then select whichever square had the highest score to do it. How's yours working here, though?
I don't know. This might not be where because once again, it's been a while since I wrote this code. This might not be where the recursion happens, but I'm taking a look here. So we have a set core puzzle is one function.
Right.
And then
the spawn core puzzle, I saw that.
Spawn core function.
And that's in the name of the function. Is you named your function spawn core function, right?
That is correct. That is the name of the function. Is spawn core function. And then there's update, which is just that is a Unity function. There's certain functions that are just for Unity.
You need that in order for Unity to be able to use this thing. Or
correct.
It's a hook into Unity that allows you to use some of Unity's features inside of your code, right?
Yes. Now there are a couple. Okay, so let's take a look back. Let's go back to the editor really quick, because I noticed that one of the things here is possibly a script. So there's a prefab item called 3ds TuneCore 2.
Okay.
That is. So we should take a look at that, because that's a different object. So this is an object. Um,
Okay, that
uh,
looks like it's sort of like the prototype of how any puzzle is built. It's built using these options. That's what
Correct.
it's
These
looking
are all
like.
the objects that the puzzle is built from. And whether those objects are on or off, whether they exist in this space or not, is what the final code determines,
Yeah,
basically.
yeah,
And what
that's
color it is. Like, is it red or is it blue? So, but this object is what is called a prefab. And what a prefab is an object that is entirely built, that might have its own code attached to it. This is one of the really cool things I love about Unity. It might have its own code attached to it, right? It is kind of like it's an example. It's like a template or a platonic ideal of an object
yes.
that you can attach to another piece of code. Like, it could be a spaceship with its own code and its own behaviors and that spawns its own objects. It
It's
spawns
like
like
a
missiles or whatever, and
yeah.
it just sitting there. And then, like, whenever like the spaceship spawning code wants to spawn a spaceship, it grabs it and sticks it into the space. So that's what a prefab is. It's like
In
sitting there and it's like
object-oriented
waiting.
programming, that's frequently called a class.
Yeah, it is. Yeah.
And so you have different iterations of a class that are exact objects, but they're all conforming to what the class is. And so
Correct, yeah.
different objects might turn on or off these squares, but this is the actual prototypical class. If you're talking about starships, Galaxy class starship, or let's see if I have one over here. I believe this right here is if I got this right. So the USS Discovery is a crossfield class ship, and there were two of them made. One of them was this, and the other one was the USS Glenn. And they both have the same overarching design, but the class is just the idea, the schematic of what a ship of this class is like. The actual ship is an object. So just because Captain Lorca blew up the USS Glenn in an episode of Discovery, spoiler, then it doesn't mean that the USS Discovery has been destroyed as well. You destroyed an object, not the class. And if you want
Or even
to,
the plans for that type of ship.
Right.
We could make more of that ship because the plans exist in some database
right,
somewhere.
the plans are a class, and then the actual ships are objects. So that's a big function. That's a big key feature of object-oriented programming.
Right. So the prefab is a class, and then what it does is it spawns out this puzzle object.
Uh-huh.
And this has a script attached to it too, which says pre-made core init. So that is another script. So we'll take a look at that.
That's going to be probably a constructor, right?
That sounds like the thing that's probably
public
going
class.
to build it.
Yeah, public class
Yeah, so
pre-init.
this.
Yeah.
Okay, yeah, this has a ton more code in it. This is like this is where the puzzle. I know this is where the puzzle building.
Yeah, this is probably doing a couple of jobs. One is to define what the puzzle is, and it probably also has some methods in it that arrange itself based off of difficulty levels and stuff like that, right?
Yeah, yeah. So awake is another. That is another piece of code, or that is another function that is part of Unity. Mm-hmm. And basically, what happens is when you instantiate one of these prefab objects, any script that is attached to it that has awake, once that script exists, it will run that once.
Right? And that's because you put it into the constructor.
Correct.
Yeah. If you didn't put it into the constructor, then when you created your object, just like if I was to build another USS Discovery and call it, I don't know, USS Challenger, and if I was to have, Challenger go to warp, as a method, it can go to warp, then it travels faster than light. But if you put that method right into the constructor, the instant that the object has been completed, it immediately goes to warp.
Right.
Yeah.
So this is stuff like bookkeeping stuff. So like if you wanted to say like, oh, as soon as the Discovery is instantiated, I want the photon torpedoes to be loaded so that I can fire them later.
So
Because
I
you
can
probably
fire them
don't want
right
it.
away because I'm going to need them
Well,
immediately.
well, maybe immediately, but you might also need them later because generally you don't use the awake function for going to warp. You wouldn't necessarily want it's kind of like bookkeeping stuff.
Yeah.
Like for example, in here, what am I doing here? It looks like I'm going through all of the objects. I'm going through all of the parts, I guess, parts of this
Yeah.
component, and I'm doing something to them. Although I don't really, I'm running some sort
Yeah,
of
you're
code on
using
them.
I'm seeing a for loop in there with an
Yeah.
iterator that goes through 70, which the number 70 I don't understand. My guess, like in programming terms, I would call that a magic number, which is that
Yeah, I think there's 70 of these squares because I think the
that
nodes are squares
that,
and
that
then the
seems to make
connectors. Yeah.
yeah, that makes sense. And I could probably figure that out, but it would be really cool if that number 70 actually was described as a variable or a constant, and it was called what that number is, like number of total possible squares or something like that, and it would just plug that in. So the code
Yeah,
would become
this code
self-describing.
is horribly commented, but there is a comment here, but it is clear is obviously it's just me commenting out a piece of code is all it is.
Yes, that's correct.
That's
Yeah.
there's not like some of this is commented. This says use this for initialization.
Okay. Well, it's in the initialization function, so that's good.
Yeah, I think what I'm doing here is I'm dumping all of the node objects. I'm creating a pointer to them in an array. I think I'm doing
Yeah.
something like that, probably.
Yeah.
But
Yeah. That seems that sounds plausible.
so I can grab them later using node,
Yeah.
using a call to node. And then start is something that happens, I believe. Start is similar to awake.
Now, I'm noticing something else. This is just a little nitpick, and I don't know what this means in C# because it's been a little while since I've worked in it. So on line 38, you have void start, and you've got a space between start and then the parens. But then on clear level, on line 48, you don't have that. There's no space.
Where's the
and-
space you're talking about?
So look at.
Oh, you
on
mean
line 38,
between
the parentheses and start, and then there's the end.
Oh yeah, no, that's just me being sloppy.
Okay, cool. So yeah,
Obviously.
cool, good. Just wanted to make sure that wasn't something that was important.
Nah, it's just syntax that makes no difference clearly because it still runs. So,
Sure does. And I want to get to a point about that. Like, I know I'm like a stickler for like clean code and test-driven development and self-documenting code, stuff like that. But I mean, no one's going to actually see the code unless they're actually coming in here to work on it. What matters is how it works on the other end. Now, when you have clean code, it can make it easier for you to work with it later on. But I don't want to turn my nose up at code that isn't written to my extreme snobby standards.
and I'm glad because mine definitely is not. So
The fact that it works is brilliant. And you clearly I mean, you got the thing to do a thing. And it's also really cool to know that this is code that is that sort of inspires your usernames, which is
yeah,
cool.
Overdroid has been kind of my handle, my elite username for years. And other people like it always bothers me when I get onto a platform and someone has taken Overdroid. It always bothers me because it's like I have the website overdroid.com. Like I'm Overdroid on Twitter. I'm Overdroid on it's like come on, it's clearly my thing. Like I think I have it.
You're an internet scraper that just goes through every single website that exists and signs you into all of them as Overdroid, taking that name as namespace forever for everything.
Yeah. Well, it's funny. I think I've logged onto stuff like before as Overdroid and then come in and tried and forgotten that I logged in. I was like, someone already has Overdroid, and then I recover the password. I'm like, oh, that's me. I've taken Overdroid. Okay, but not other times people have taken the name, which always makes me a bit grumpy.
Well, Joseph,
So
it is about time that we start to wrap this up and start to talk about what we learned today.
okay.
But
I did want to see if I could figure out where this recurring function is.
Yeah, let's see if we can find that.
Assuming it's make puzzle. Does this call make puzzle anywhere? This looks promising.
While make puzzle loops is greater than 0, that's a good sign. And it says make loops. That's I like that comment. That's fun.
It's a really clears up a lot of stuff. Make puzzle loops. Scramble puzzle, node wrap. Yeah, I don't know. I don't know where the recurring function is.
Well, you do call like, well, all right. So we've got.
I know it's in here somewhere. I know there's a recurring function in here somewhere. I remember writing it. I remember going like, I wrote a recurring function for a reason.
That is always very empowering when you do something like that. Yeah. And it is also like deadly complicated if you get it a little wrong, because it can like a recursive function runs away with itself if you don't do it right.
Yes, for sure. I guess it would be something with parentheses after it, right?
Yeah, maybe start with those top level method definitions that you've got in here. So one say void, one says make puzzle. You can also do a command F and then look for that name.
Yeah, I can search. I just feel like it should be easier. Maybe it is in one of these smaller functions. Scramble puzzle, is it in scramble puzzle? Scramble puzzle doesn't seem to be calling itself. Node wrap. There's a yeah.
Yeah, you can get lost in here, and one solution is to just take it chunk by chunk, very deliberately, bit by bit, and then eventually we would be able to find it. But if you were to command F make puzzle.
Yeah, let's see if we can find make puzzle in here. Wait a minute. Make puzzle loops? No, that's not it.
I think that's a constant that you have.
Yeah.
Make puzzle loops is not, although it sounds like a function because you've named it with a verb, I don't think that's actually it's actually a function.
Was it scramble puzzle? Anyway, I feel like we could do this for a while, but you wanted to talk about what we learned today, which hopefully is something, because my code is spaghetti.
It happens so much. I mean, I go back and look at my code from a couple of years ago, and I'm like, oh man, who wrote this thing? I can't find anything in here. And it was me. I did that. I did that to myself. Every bit of code, I think one thing that we can take away from this is that every bit of software in the world, someone actually wrote.
Yeah.
That
is true. Someone wrote that software. Yeah. I do feel like I was very clever, like the way, because when I first did this was like years ago, I was like, how do I make a puzzle that's solvable? How do I make sure the puzzle is solvable? And I was beating my head against this wall. And there's a really obvious solution to it, which I don't know. We'll see what would you do, Ian, if you wanted to make a puzzle that you knew was solvable? For certain.
I would break it into lots of little parts, and I would test drive each of those little parts and make sure that those things always worked. Then after that, I think you're trying to do a mathematical algorithm, though, or something to solve that problem for yourself. That's tough. That would take some thinking, but
there's actually a really easy solution, which is you build a puzzle that's solved, and then you mix it up. That's how I solved it. Like you just take a Rubik's Cube, you make a solved Rubik's Cube, and you just scramble it.
And then because of the fact that you've scrambled the solved version, that
there's an end state that is solvable.
Right.
Yes.
That's genius.
Yeah. Well, I don't know that it's genius, but I feel like that was like when I thought of that, I was like, oh, that's so easy. Why didn't I think of that at the beginning?
It's
Like,
just a
but
Rubik's Cube. It's just a
yeah.
really weird Rubik's Cube. Now, once you understand that, then yeah, the rest of it just starts to, everything falls into place, quite literally.
But I do think it's so interesting the way, because it is like the way computer programmers look at when you're coding, you look at a problem. Because I did for a long time, I was like, I gotta figure out an algorithm that'll figure out if the puzzle is solvable. How
Yeah.
do I do that? And I was like and I was like, oh, wait a minute, I don't have to do that. Why? Well, like it's just, yeah,
Start
I
off
just
with like,
make,
start at the end, and you start with the desired state, and then you move backward.
yes,
And
yeah.
and each of your levels is just, you just scrambled it even more. You just went even further scrambling it, right?
Yeah. Yeah, there's like a little thing basically because all the red cubes are the you want to turn it blue, so it just like looks at it. It'll like first it's a bunch of randomization, and then it randomizes it some more until there's enough red cubes, and then it's like, well, then that's going to take a while to solve. So that puzzle is scrambled. That's it.
That's
Yeah.
yeah, and that's where your recursion will come in. It'll come in when it's, the level is how many times to recurse over that function. The function just scrambles it once, and then
Yeah.
and every time you recurse it, you then give it the scrambled puzzle, and then you scramble it again, and then you give it that scrambled puzzle, and you scramble it again, and
Maybe, and then it just checks every time until there's enough red cubes, and then it's like we're done.
and then it's like, oh, I scrambled it enough now. All right, cool, good, and then off it goes. But yeah, maybe you also did a thing where it's like, make sure there's enough red cubes. But yeah, that would, if this is essentially a Rubik's cube, which the way you're describing it now, like it makes so much sense. Like
Yeah, I wonder if we could see like a complicated, like a more a later version of the puzzle. There's a way to. Where's the Somewhere there's like an object that determines what level it's on. Good nodes, active nodes, end level. Where is it? There's like might be in the player item. But you could see, for example, the player object
yeah,
has these prefabs.
right,
Like whenever I in the game fire a bullet, it's instantiating a bullet object,
right,
right? Because it has this zappy bullet
right. It's
object.
building a bullet, and then as soon as it is built, it fires it.
Right. And the bullet itself has a code attached to it that, like, if it travels far enough, it just disappears.
Right.
Yeah.
So that way you don't end up creating memory leaks by having all these bullets zapping off into the distance and having the computer still keeping track of them when they absolutely don't matter.
Right. Exactly. Yeah. Exactly. Yeah, I'm not sure how. There's a way. In here somewhere, there's like that's not it. There's an object that has the level. Ooh, there it is. So if we turn this up to 80 and then I solve the puzzle, let's see, it should give a more complicated puzzle for the next one. Yeah, see, this puzzle's much more complicated and there's a lot more attached things, right?
Oh,
See
yeah.
that? So you got to figure out how do I get these all to be blue? How do I, you know what I mean? There's a way to do it because it started from a solved state, obviously.
Right.
And
that means that you can always you know that you didn't do that wrong because it had to start from a solved state.
Right.
Huh. Well, that's really cool. So I don't want to keep you too late because I know you've got a lot of stuff going on. But I do have a couple of questions for you.
Okay.
All right. One, what's the most important thing to remember about developing software?
Oh, yeah. You told me what these questions were at the beginning, and I don't think I really even thought of an answer for them. I think what's the most important thing about developing software? I think it's that get in there and get dirty. I feel like a lot of people feel like they're going to break the computer by coding it, and it's like, no, this is about it's Tinker Toys, man. Get in there and and build some stuff and let it fail, like just like improv, like fail to learn. You know what I mean? Like you're not
Yeah.
going to break the machine. You're not going to break the machine. Play with some stuff. See what if it goes into an infinite loop and you have to reboot. That's fine. Like you know what I mean? Like it'll be okay. It'll be okay. That's I think the most important thing.
Yeah, yeah, totally. Yeah, can't. That's one of the other reasons why I say like clean code is one thing, but it's more important to get your hands dirty first. You can clean it up afterwards.
Clean it up afterwards. Yeah.
Yeah. All right. Second thing, if someone wanted to get started with developing games with Unity or just software in general, where should they begin?
On the internet. I mean, you can teach yourself anything from the internet. Like for Unity, they have like a series of videos you can watch.
Yeah.
They want people to use Unity.
Right.
The people who develop Unity. That's the other thing is like there's a whole series of tutorials. If you want to learn Unity, you can start in the very basics. They'll explain this development environment. They'll explain what everything is, you know, and just walk you through it all. And yeah, and eventually you'll be learning writing functions in C# by
And
the
if
end
you
of it.
get good enough at it, which all you have to do is just apply it enough,
Yeah.
and learn it enough. And if you wanted to get a job doing that, there are people who will pay a lot of money because you spent your time going through those tutorials, which were free.
Yeah. Yeah.
Yeah.
Yeah, and then, like I said, there's a big, there's a ton of people out there. There's a huge environment of people out there who will, who help you out. You can even ask on forums, like if you're
Mm-hmm.
not sure how something works. If you can't find the answer somewhere, you can ask, and there'll be people who will answer you within a
Yeah.
day, if
I
not sooner.
I mean, if I can't tell you how many times I've relied on that myself, and how much that because of the fact that I rely on that, I give back too. And I'm, not alone in the world of software developers who, dedicate themselves to teaching other people. Just about anybody is, if they've got a few minutes, they'll spend it, helping you out. So
True, true.
yeah. Of course, you got to put in your own work. I mean, nobody's going to eat your lunch for you.
No, and I think like do a little bit every day. Like every day you should, just spend a little time on stuff. And you're gonna have to learn some math too. That's the other thing is you can't be afraid of math. But start out. You can go to like Khan Academy and just do some learn just a bit of algebra. Really is
Yeah.
all you need. You don't need to know what trigonometry. You don't need to know trigonometry, but you do
No.
need to know like basic algebra. The plus minus division
Wait.
and having some variables in there.
Yeah, when I
But
first
it's
started, I was
yeah.
thinking like, oh, I should learn calculus. And
Oh,
do you know that I did not learn calculus?
good. Yeah, calculus is hard.
Totally unnecessary. And to describe that in code, again, not particularly necessary for me right now. At some point, if I need it, I now have enough confidence in my ability to learn things that I can actually go in and do it. But I've had no need to do that. So yeah, you don't need nearly as much math as you think you do. Yeah, I'd say that naming things really well and trying to write it as if it is prose will help you out.
Yeah. Yeah, I could definitely do more of
Yeah.
that, as we've seen from looking at my code today.
Yeah. Okay, so I have some people to thank at the end of this episode. So let me go ahead and do that. First of all, my production liaison is Matt Pittner. Thank you, Outpost 13. My designer is Aaron Harvey, who has a show called Infinite Trek. It's on Saturdays. They've been going through, they're just about to start Discovery Season 3. I'm very excited about that. My marketer, Lucas Fanasic, who is away right now, but frequently you can find him on Two Liars, which is on Thursdays. Botmaster's Cody Bushy. He has a show called An Actor Unprepared. That is a great show if you want to see into the acting process. And you get an actor, a director, and a writer, and they create a piece right there on the spot. And the music is by Arlo Sanders and Alex Kahn, who have a Spotify channel called Made Up Music, where they have made up music here on the channel to do that. So Joseph also has a show on the channel. And not just one, he's had several. He may have more in the future. Who knows what the future may hold. But I do know that he is co-host on the I Effing Love Whiskey podcast and show.
Scotch.
You can tell what that show is like already.
That's a good one.
Joseph, thank you very much for being here. And
thanks for having me, Ian.
Yeah.
I had a lot of fun. You're
right.
such a smart dude, and I love that you love coding.
You know, I love that you love whiskey and that you do game development and that you have been so nice to me in so many ways. I'm in great company. But yeah, now is the time at the end of the show when we have a very awkward goodbye that usually happens at the end of any software call. So let's try and make it as awkward as possible. Are you ready?
Okay.
I'm gonna shut this thing down.
All right.
Hold on. Wait.
Okay. Are we? Oh, are we? Are we done? Or?
Hold on. I need to mute us both now. The video is on, but we're still not muted.
Okay. Oh, that's okay. Well, I guess talk to you next time. Or
Oh yeah.
was there another?
No, there's not. All right. Bye.
The only steps I can, steps too high. I'm just a man. If you see my face at your hour of death, don't shake. Don't shake in your boots, no, don't you fret. Cause I'm gonna take you down where the beats are pumping, down to hell where the lava's jumping. In the mountain, lava's jumping, down to hell where the lava's jumping.
Let yourself fall, cause you'll only get higher. Let yourself drop like a bee on fire. Living half dead, so you might as well drop. The f***ers can't find you, the beat don't stop. The beat don't stop. It'll never stop.
I walk this life. The only steps I can, steps too high. I'm just a man. I walk this life. The only steps I can, steps too high. I'm just a man. When you start saying a mountain is a mountain, a river is a river. Well, living Zen, a mountain is not a mountain, a river is not a river. After learning Zen, a mountain is a mountain, and a river is a river.